Let x equal u over v and y equal uv. We'd like to compute the Jacobian j of uv and the corresponding area element dA. So in other words, if we were interested in computing a double integral over a region of some function of x and y, dA, and maybe it would be useful to transform to another coordinate system, as we've seen with polar coordinates, where x is r cosine theta and y is r sine theta, then that has an effect on the area element. And the rule is that dA is the absolute value of the Jacobian of the transformation times du dv, in this case with the variables u and v. So with polar coordinates, it was the absolute value of the Jacobian of r theta times dr d theta, and this Jacobian ended up being r, and so we got r dr d theta. So let's try it for this transformation. The Jacobian, by definition, is the determinant of the 2 by 2 matrix given by partial of x with respect to each of the variables u and v, and partial of y with respect to each of the variables u and v. So we have to compute these four partial derivatives. That will give us a 2 by 2 matrix, and then we want to take the determinant of that matrix, and then dA will be the absolute value of that determinant times du dv. So let's compute those partial derivatives. The derivative of x with respect to u, so x is u over v. V is a constant when we do the derivative with respect to u, so we just get 1 over v. And the derivative of x with respect to v, so let's recall the formula for the derivative of 1 over x. That's negative 1 over x squared using the power rule, because 1 over x is x to the negative 1. And when you take the derivative, you get negative 1x to the negative 2, which is what I wrote here. So the derivative of x with respect to v, u is a constant, and the derivative of 1 over v would be negative 1 over v squared. So we get negative u over v squared. And then in the denominator, we need dy du, the partial of y with respect to u, which is just v, and the partial of y with respect to v is u. So we need the determinant of this 2 by 2 matrix. So the determinant of the matrix A, B, C, D is AD minus BC. So there's a formula for determinant, and we'll apply that here, and our determinant is 1 over v times u, which is u over v, minus, multiply these two together, let's see, what is that? Minus u over v squared times v. V over v squared cancels, and we get a double negative, which is a plus. The v over v squared cancels, this v cancels with the square, and we get another u over v. So we get 2u over v. And so then dA, the area element in the coordinates uv, in the uv coordinate system, will be the absolute value of the Jacobian. So the absolute value of this is 2 times the absolute value of u over v, and then times du dv. So there is our area element. So if we were doing a double integral of a function of x and y, then, and we wanted to change the variables x and y to these variables u and v using this transformation, then dA would turn into 2 times the absolute value of the ratio u over v times du dv.